Good afternoon, ladies and gentlemen at the REI Europe. This is Sascha Krause-Tuenker from Next2Sun from Germany. Unfortunately, I'm not able to be in New Delhi at this time, but I'm very happy to get the chance to introduce you to our Agri-Photovoltaic system via video conference. I'm going to show you some slides about our system and its application. And I'm quite interested in the discussion with you about potential application in India. So let's get started. So I want to tell you a little bit about our quite young experience with our system since it's new developed. And of course, the experience is only as long as the system exists, which is about 1.5 years approximately in a bigger plant. First, I want to show you the system, which is quite different from what you might already know. I wanted to introduce you the electricity production advantages, as well as the advantages for agriculture we see in the system. And at the end, I wanted to show you a special application, which is called solar fans. So first, the introduction into our system, our concept, which is quite different from what you might already know. Normal Agri-PV systems have some kind of roof above the agricultural ground. Our system instead is with vertical mounting and some space between the rows of let's say 8 to 20 meters for the agricultural use. Here you see our plant in southwest of Germany, where the row space is about 10 meters. We need more than 8 meters due to shadowing reasons, to avoid shadowing, lowering the electricity production. And in this plant we have 10 meters, and you can see that the tractor with the mowing system, which has an size of approximately 9 meters, fits in between and is able to work in between quite efficiently. Our system only takes a very small space in the whole plant, so there's a lot of space left for agricultural production. Let's have a look at the electricity production, which is also interesting since there are some advantages compared to other systems you already know. First, let's talk about the production volume. Since surprisingly for us as well, it's more than you would expect from an. We have around 10 to 15% additional production compared to a south-orientated plant with monofacial models. We understand now why it's even higher, since especially in midsummer, conventional plant loses some production due to the point that the sun is even especially in the morning and the evening hours behind the modules, and you have no production at all. That's something we avoid, since we especially have high production in the morning and the evening hours. The second effect which increases our production is the albedo effect, especially, for example, at noon. We should not see any production from direct irradiation, but still due to reflection, we see about 20% of photovoltaic production also at that time. The second point is a production profile. if we are looking about we are looking at the conventional systems, we see an increase of production in the morning hours, a peak at noon, and decrease in the afternoon. Our system instead has two peaks, one in the morning and one in the evening, and decrease during the midday. This has also on a standalone basis an advantage, since it's nearer to the electricity demand during the day. But I think more interesting is the combination of both systems, since if you combine both together on a, let's say, one-to-one basis, you get a quite a stable production curve with an high increase in the morning hours, a stable production during the day, and decrease at the later evening. And so our production, our system is able to stabilize the renewable energy production and bring it nearer to the electricity demand, which I think is a great advantage. Here we have some experiences from Germany, where we also see some, also some effect in the prices. In Germany we have some 40 gigawatts already installed, mainly with south orientation, and which leads to at sunny summer days we have a high production at noon from the conventional PV plants, which already decreases the prices at noon even below zero, we have to say. So we have a spot market curve which is high in the morning and the evening hours and goes down at noon. Yeah, and as you can see, it fits very well to our production curve, since our production curve follows the spot market price with the high production in the morning and the evening hours when the prices are high. On average, we saw from our system so far market price about 0.3 cents higher per kilowatt hour than the average market price of solar power in Germany. So due to this outperformance and from the volume as well as the price side, we get some additional revenues of 20 to 25%. As you also saw when you look at the system, it's not very complicated to build. It's not that difficult like building a roof or something like that. So overall, we expect or we already have seen a difference in the price for building such a plant is on average, let's say around 20%, with due to compared to a conventional PV plant with a south orientation. This 20% additional cost already include the bifacial modules instead of the monofacial ones, as well as some more effort we need to mount the system. And as you can see, this additional price for the system is already covered by the additional revenues. So we are completely competitive, and the advantage of using our the field for agriculture is without any additional costs. So let's move forward to the agricultural perspective. What is our advantage there? Of course, our system offers a wide range of ecological and agricultural uses. We can do, of course, conventional agriculture, as you already have seen. Livestock farming is also not a problem. We already tried, and no problem at all. Organic farming should be an alternative, as well as some ecological enhancements, for example, through extensification or in the row spacing between. The potential crops we could imagine for the production in between is, for example, of course, potatoes or carrots or different types of beets, but also low-growing cereals and rice, but with a restriction only up to 75 centimeters. The lower row of modules is mounted around a meter above the ground. So, of course, we do not want to have some shadowing effects due to the crops in the summertime. And that's the reason why it should not be higher than 75 centimeters. But yeah, as far as I know, there are different kinds of cereals and rice as well, which do not grow higher than 75 centimeters and are able to be combined with our system. Another possible advantage we see is reduction of wind erosion due to the north-south arrangement of the modules. They counteract especially east and west winds. And if we are talking about northern Germany, but also parts of India as well, as far as I know, we have a main west wind direction, which of course causes erosion. And if we have our module rows in between, they break the wind and decrease the wind speed at the ground, and also lower the evaporation due to reduction in wind exposition. That should also help to keep the ground stable. Yeah. Another possible advantage is support of biodiversity. For example, by flower stripes under the modules. Yeah, so as I already showed in the first picture, we have, let's say, if we have a row space of 10 meters, we would have around 9 meters for agricultural use and a meter more or less left directly under the modules, a little bit left and right. Which could also be used, for example, for flower stripes to also protect against erosion, and which could be an interesting habitat for a different kind of flora and fauna to increase the biodiversity. Furthermore, we have a special application I wanted to show you now, which is yes, a product we built out of our system. It's a solar fence. Here we have a picture, and it's a combination of our vertical PV production system, only with one row normally, which is also used as a fence. Yeah, we have a great flexibility for the kind of fence we would mount below our modules, for example, wire mesh, bar grill, or also even for personal purposes, privacy panel, to use it as a fencing. Here we have a picture from our first installation in Austria, where we have this combination of fencing and electricity production And as you see, we also have an additional advantage, which is a shadow for the livestock. You see all this chicken here are obviously quite happy about the shadow from the modules and are more or less all in a place where they have the shadow. So this is our system. I wanted to introduce you, and I'm quite happy to discuss the advantages and maybe disadvantages and possible applications in India with you. Thanks a lot for your attention, and looking forward to our discussion.